first three main types of learning. Supervised learning. In supervised learning, what it means is we have a data set with labels for the machine learning algorithm. In the unsupervised learning, it is nothing but just a data set, and the machine learning algorithm finds the relationship present in the data. So these are the two main categories that I've discussed so far. And the third one is reinforcement learning. Here there is no data set at all, and the machine learning algorithms interact with the environment to learn. Reinforcement learning is the is a kind of learning where you do not have any data set. It has to learn from the environment, like a baby. It tries to learn by its own by interacting with the environment. So here is one example. Uh, in this case, we do not have a data set at all. So for example, if you take this problem, this is to find the shortest path. To find the shortest path, there are states, all cells, and the action. Okay, the action means moving from one place to another. So through the action, we can visit the neighboring. So what this example does, how we are going to implement this reinforcement algorithm to solve this problem. What is the problem here is to find the shortest point. The starting point here is the red cell, and the ending point is green cell. And we have certain blocks here that blocks the movement. So here you cannot move in. This cell cannot be used. So it is a block. Okay. So what we have to do is we have to move from one cell to another cell. The agent means uh, the person or the character, whatever you can take. So in real life examples, we can take the whatever it is based on this application. We will take that. So here the agent means that is the person is trying to move from here to this point. So you can move towards upward and then take some right, and then you can reach the end, that is green. Or he can move from this point to this point, or he can move from here and he can move this way. So he can choose any path. He doesn't know anything at all. Okay, so he is here and he wants to move one by one, one by one, one by one, and finally he will reach the green, obviously. Okay, so upon doing actions, the agent receives a reward or penalty. So how the agent learns is when he moves from this point to this point, he's learning something, and then to this point he's learning something, and then when he reaches this block, he's learning something. I cannot move here. There is some obstacle is here, so he'll get some penalty like that. And then when he moves from upwards, he will not get any penalty like that. He will move, and finally he will move one by one. And when it reaches the end point is the green one, you will get a reward. So when he moves from one cell to another cell, he may get reward or he may get penalty. So when he get penalty, he will not move into that place again. He means the agent, okay? And like that, the agent will work to learn the environment, and the agent may get reward or penalty based on the actions. Okay, so that's what explained in this block diagram. The agent takes an action and moves in the environment. In the environment, the agent may get the reward. Okay, and in the environment, the agent moves from one state to another state, isn't it? So he's moving from this cell to another cell. So cell or state. Okay, he's moving from this place to this place. That's called state. Okay, so two things are happening in the environment. One is it's moving from one state to another state, and while it's moving, you may get reward or penalty based on the environment. So that's all about reinforcement learning. How this reinforcement learning works, I give a quick introduction on that. So the next point is where these reinforcement learnings are used. So in the games, particularly in the games, they are using reinforcement learning. Um, so there is lots of online games so popular nowadays. They are using the reinforcement learning where the agent the AI player has to learn by itself and has to play with the human being. And self-driving cars. So that is another area they are using this algorithm. And there is not only cars, self-driving helicopter, drones are also nowadays popular. So in that case also they are using AI algorithms where the cars or any vehicles learn by itself how to fly, how to move from one place, how to navigate the obstacles, everything the cars learns, okay, by its own. And then in the finance also, they are using this uh, to maximize the value of the portfolio. How so there also they can use and vehicle routing problems. So there is lots of applications which can have nowadays. So uh, why the reinforcement learning is so popular nowadays is reinforcement learning is also using deep learning nowadays. So that's why it becomes so powerful. So in our case, we are not going to use deep learning. We are going to read what this reinforcement concept, how the reinforcement works. So that's the aim of this class. The next point is Markov decision process. So this is the main algorithm or the main method they are using for learning the environment. In the machine learning, the environment is formulated as Markov decision process. Let's discuss about this Markov decision process. So the first thing that we have in the Markov decision process is set of states. So in the previous example I have shown, you will have a set of states. Anything. If you are taking this finding the shortest path game, or if you take a TikTok, or if you take a self-driving course, whatever it is, you have a set of states. Okay? That is the environment. So set of state. Okay. And then set of actions. And the agent has to move from one place to another place. Either the agent will move upward, downward, left or right. Okay. So there is possible ways that the agent has to move. And then uh, the next state depends on the actual one exclusive. So what is this Markov? Why the Markov property is says is the next state. If you take in this example, it is moving from this cell, red cell to this cell means the moving from one cell to another cell is purely depend on the actual state. So or the current state that we can say. So, for example, if the agent is here and it is moving from this point to this point, so it is based only on the current state. Okay, this is not depends on the previous states. So, how it is coming here does not depend on the moving from this point to this point. So, when the agent wants to move from this point to this point, it purely depends on the actual state or the current state. So, that is called Markov property. Okay. So that is the third point. And the fourth point is when it is moving from one point to another point, one cell to another state, one state to another state, you will get a reward function that I already told. So based on the environment. And then gamma discount factor is another one. What it means is it prefers the reward now, not in the future. I will tell you what is that while explaining the program. Okay. So here you can see the transition probability means the next state S prime is depends on x comma s is the current state and a is the action. So if you take a TikTok toe game, so this is the game that we are going to implement in our class. So most of you familiar with this game. Okay, so you have 9 states here. So I can take we can use difficult projects also, but it's very difficult to learn and then implementation is also difficult. So that's why for learning purpose we are taking this tic-tac-toe game because we have only 9 states in this case. So in this line, there is some rules for this game. So the person has to place his stickers either in the horizontal or vertical or in the diagonal 3 cells. So then the person will win. So how the reinforcement learning can be used to learn the TikTok game is okay. So the in the environment is nothing but the cells on the board. the agent, the computer player makes a move according to the board. So, according to this, in this board, wherever the cell is empty, any player, either the computer or the human player, can take a use that board. Okay, make a move in that. So, where it will put a X. So, when the game will end, maybe the agent puts all the threes in this diagonal or in the at this diagonal, horizontal or vertical. If he plays all these three tickers, then the agent will win. Once the agent will win, we will give reward. If the agent loses, you agent means the computer. Okay, now we can replace that with computer because we are going to play with the computer, right? So when the computer lose, we go into the penalty. Okay, so that's the concept. So the reward is once the player computer wins, we give the reward. The algorithm will give the reward, and that is the environment. Okay, and if the computer loses, you will get penalty. Okay, so the same thing is applied to this finding the shortest path game also. Okay, so we have two different types of environment. One is deterministic environment. Another one is stochastic environment. What is this deterministic environment? Means you have a state with the cells, okay, and then you have to pick a cell. So this cell is indexed as 0, 0, 0, 1, as 0, 2, like that. So we have to pick a cell. So when you pick a cell here, that is 0, 0. So that is called action. When you have a state and you are taking a action, so and definitely you will reach that state, isn't it? When you have a state and if you take action to the particular cells, then you will reach that state. So that is called deterministic approach. Okay. So what is this stochastic means? It involves randomness. Okay, like coin toss. So when you're tossing a coin, what will happen? We don't know whether head or tail comes. We cannot determine that. So that kind of environment is called stochastic environment. How will you determine? Based on the probability function. In the deterministic environment, we don't have that problem. We have when you want to reach a particular cell, and if you take a necessary action, definitely you will reach that state. Okay, we have to keep that in mind because in our games, whatever the games, chess or the shortest path, we have a deterministic cell. Okay, and the discount factor. What is that discount factor means? Gamma. So I will tell you what is that. I already explained that in the while discussing the Markov decision process. Gamma factor is nothing. It gives prefers the reward now and not in the future. Prefers the reward now and not in the future. So when the agent moves from one state to another state, it will get the reward there itself. Okay, it will not wait to get the reward at the end. So that will be determined by discount factor or gamma. So the value will be 0, 1. So all this keep in mind while we discussing the um, working of algorithm. We will understand all these concepts better. And cumulative reward. So let's talk about this reward. So cumulative reward is nothing but R. It depends on the gamma factor or discount factor here, and R is the reward when the agent moves from one cell to another cell. The agents will get a reward. So the summation of all those things is called cumulative reward. For example, the agent at t equal to 0, it is in one state and it is moving to the next state, that is t equal to 1. At t equal to 0, the agent is getting some reward, that is R now. And from moving from one state to another state, actual state to the next state, it is getting R1 reward. and plus it is having some gamma factor also. So what is that gamma or discount factor is? It will prefers the reward now and not on the future. When the gamma equal to 1, it means the rewards now and the rewards in the future are same. When gamma equal to 0.1, that is very less, it means we focus on the rewards only in the present. Okay, so we keep that in mind. And then from this state to this state, when the agent is moving, it gets the reward like this, R square R2. So that's what this cumulative reward contains. Okay, final reward, the adding up of all the rewards. Okay, the next thing is value function. So what is this value function is? Here the function represents how good the state is for an agent to be. Okay, the agent is moving from this point to this point based on the values in the cell. So the agents have the reward from moving from one point to another point. So that is also there. And each state has some values also. Okay. Each state, this value will be determined by the expectation of the cumulative reward. So how this value is formed is, this is by the expectation of the cumulative reward. If the value of the cell increases, the value of the cell increases when it is approaching the terminal. Okay. So when it is moving in the right direction, the value of the cell is increased. That means the value of this cell, this cell, this cell, this cell will be more when compared to this cell because it is near the terminal. So that's why the agent learns we are moving in a correct direction or in the wrong direction. Here the value from moving from this point to this point, the value will be very less or in the negative. So the agent thinks, so this is not a good option to go in this direction. So it will choose the another path. So in this way, the agents can learn the environment using this value function. So this is the example for this. So each and every cell has some values. So how this value is updated? It is based on the reward. Okay, it is based on the reward. All these things we will see by the illustration. Okay, so this is another representation of this. Each and every cell has 4 values here. It may have multiple values. So what this value represents is 0.7. This direction is when the agent wants to move to towards this the direction, the value here is 0.7. Towards down, the value will be 0.4. Towards the right, the value will be 0.6. Towards the up, the value will be 0.9. So the agent will choose the maximum value. Okay. So all those things are combined together and forms a Bellman equation. So we'll come back to this exploitation and exploration. So far what we have discussed is reinforcement learning and the Markov decision process. This Markov decision process is nothing but a Bellman equation. They are saying it is a mathematical concept, is an approach. So we will convert that into Q learning. So we can say like other name for that one is Q learning. Okay. So this is the important approach called model free approach that we are using for the reinforcement learning to learn the environment. Okay. So what this Q learning says is the agent will not try to learn the model of the environment such as state transition or reward function. The agent finds out what are the good moves by trial and error. So you will not have initially you will not have any information on the cells or the states. All are zeros. It's an empty environment. How the agent finds out is which one is good moves by the trial and error method. That's why it is called model free approach. It is based on the Markov decision process model. So that we have discussed. So this is the equation for this. Okay. And Q of S comma A is nothing but the state value. Okay. And that is nothing but Q of S comma A and then plus alpha R of S comma A plus gamma max Q of X S prime comma A prime. So that is the next state. And then minus Q of S comma A, that's the old value of the cell. So this equation is called as Bellman equation, or you can call that as Q-learning. Okay. So it is from the Markov decision process. So how the agent will determine to move from one state to another state is based on this values. Okay. So let's see. This is the old value in a cell. Imagine the agent is standing in a cell. That cell value is Q of S comma A. It has some value. And then it wants to move from this point to another point. So how that another point is determined by, it will search the other all other options, that four options that we shown in the box, no, right, left, we have four values. It will check the maximum of all these four values. From that it will take a action, and that value is associated with gamma. Gamma is the discount factor. We know that when gamma equal to 1, the current reward and the future reward are same. When the gamma is 0.1 or like that, it will determine only the present reward. So that is the concept for this one. And this is the reward for that action. So it is moving from one state to another state based on this values, and you will obviously it will get some reward or punishment for that. Okay, so that is R of S comma A. And with that you have the learning factor. So how much it is learned. So we have some factor for this also. It is also from 0 to, okay. So this value minus this value is your new value. That means the learned value minus the already had the actual value gives your some value. So that will be updated on your cell, and that is called your Q value, updated Q value. Okay. So it will be very difficult to imagine this, okay? But I will show that in the illustration. So how this algorithm works is, it has gamma, alpha, and reward values, and we have initial condition all are zeros. And for each episode means the the agent has to move from one episode means from the starting point to the ending point. Okay, it selects a random initial state, and then the terminal state hasn't been reached. So it cannot reach by first step. It has to move from all possible A actions. It has to take one by one action. It has to move from for the current state and use this action to go to the next state. So that's what we have discussed. And while it moving from one state to another state, the Q value will be updated on the state, and then S equal to S. So now it is in the next state. The next state is your current state, and then N, so and then N. So like that, it has to uh, do multiple times to reach the terminal state. So one episode means the agent has to move from one point starting point to the terminal point. So gamma means gamma is nothing but the discount factor. The agent tends to consider only the immediate reward. It is closer to one future reward with greater weights. Alpha is the learning rate. It's also 0, 1. So these are some factors that we are using to make the agent how much it has to learn and how much it has to greedy for the current rewards, because we need current rewards. Okay, then only the game will be end. Otherwise, it will not end. And then episode. Episode is the one training session. In every episode, the agent explores the environment, receives rewards until it reaches the goal state. That's a quick reminder. Now, with this example, we can easily understand how this Q learning function. So this is an example to reach the agent wants to reach the terminal +1, and this is the penalty area, wrong terminal, and you have the correct terminal. The agent has to move towards the correct terminal. Okay. So how we can the agent will use the Q-learning to reach the destination that we will see. Initially, like I already told, all the Q state. So why it is called Q-learning means we call this as Q. Okay. All the in this cell, all the states, all the Q states will be zeros. You can have four values here: right, left, up, and down. All are four values. So that is Q of S comma A in this state is all zeros. Initially, all are zeros. You don't have any values. Next step in the algorithm is the agent choose the cell randomly. Isn't it? So it chooses the cell randomly. Chooses this one. Okay. And then the agent wants to move from this state to another state. So this is now the actual state, and it wants to move to the next state. Now we'll see how this Q learning will update it. So this is Q of X comma A. Okay, current state. So that is 0 comma 0. The state number is 0 comma 0. Okay. And then it is moving in this direction. The direction here is towards the right side. So when he wants to move to the right side is because there is no indication or there is no best way here. All are zeros. So it has to go randomly. It chooses this path. So this direction. The agent chooses this direction that is indicated here. And then you can see the Q-learning equation based on the MD Markov Decision Process. Q of S comma A. Q of S comma A is the current state, yellow. What is the values here? All are 0, so we get 0. And then here 0, so it sees only this value, so 0. Plus the learning factor will keep as 0. And then this one, this area, no? This area is nothing but the immediate reward. Will it get any reward here? Because all are zeros, here also zeros, it is not getting any reward. So the reward will be only at the end. So getting 0. Plus this gamma factor we are keeping as 0.99. Okay. And then, so this is, we are keeping this, this gamma and alpha, we are saying this. And then Q is S prime of all state. So it has to move from this point to this point. It is seeing all this state. When you see all the states, all are zeros. So we are getting 0 here. Minus the actual value, that is also 0, 0. So you will get all are zeros. So there will be no updation here. And the next step is the agent again tries to move from this point to this point. It chooses this direction. So the current state of the agent now is 0 comma 1. So that means this one, 0 0 is this one, and 0 comma 1 is this state. And the agent wants to move from this to this point. Again, it sees all the cells. There will be no values 0. All are zeros. Here also 0. Here also 0. So there is no updation. Again, all are zeros. So again, we have zeros here. Okay. Now we can see the changes. When it moves from this point to this point, this cell is updated as, this state is updated to, for this direction as 0.5. How? Let's see. Now the agent is in 0.2 and it wants to move to this direction. When it wants to move to this direction, you have +1 reward. Okay. So now see how this Q-learning get updated. So the current state is 0. Current state is 0, isn't it? Okay. And then initially it is 0. And when it tries to move towards this direction only, it gets 0.5. Okay. That is after executing this equation. So what is happening is 0.5 is the gamma and the reward R. What is the R? R is the reward. Reward is 1 plus 0.99 is the gamma and all actions. So it has to see all the actions. There is no, so this is not a cell, only reward is there. So 0, 0, and you are getting 0.5. So that 0.5 is been updated in this direction. That is four values are there. Okay, this is for downward, this is for left, and this is for upward. and in this direction only the value is updated, because here only you have the reward. Okay. Now similarly again it chooses this random place, and then it sees all the current state is 0 and wants to move again in this direction. Again all are zeros. So there will be no updation when the agent tries to move from this point to this point. And when the agent wants to move from this point to this point, it sees again. So this is where you can see the difference here. Um, Initially, Q of S comma A is 0 because all are zeros, plus alpha is 0.5. Okay. So these are default. And do you have any reward here? So there is no reward. Only the reward is +1. So there is no reward. And maximum of gamma is 0.99. Maximum of Q of all actions. So it sees S prime. S prime is the next time it wants to move. It sees all the values. So when it sees all the values, it is having the maximum value 0.5. So that 0.5 will be updated here, and the equation becomes 0.04. That is the learned value updated in this Q. Okay. So when it moves from this point to this point, again there will be updation because you have the reward and it is updated as 0.5. So like that it will move multiple times. Multiple times it is moving from one point to another point, one point to another point. And then finally you will have lots of values here. Okay. After many episodes, you will have lots of. Now we have entered into 2 episodes. For example, 10,000, 40,000 episodes. The agents moves from one point to another point. Mean it learns the complete environment. It knows where to go, where not to go. Okay, this is how this Q learning will work. So let's see what will happen here. So it again moving from this point to this point, there will be no updation, and it is moving from this point to this point, there will be no updation because all are zeros. And if the agent wants to, here also the agent is doesn't know where to go, isn't it? So either it can go upward or it can go to this point, okay, or it can go back. So the agent taking a random decision because there is no indication, no values inside the cell. So if the agent wants to move to this -1, means what will happen? Initially all are zeros, this Q of S comma 0 0, and alpha value is default. And if you have any reward, when it goes from this point to this point, you will get there is no reward. You will get -1 as your punishment. So it's not a reward, actually it is a punishment because it is moving in this direction. And then there is no Q values here, and then you will get -5 indicated in this direction. Okay. So that is how the algorithm is updated. So here move from this point to this point, all are zeros, and it moves from upward. Uh, you will get the value has been updated when it moves from this point to this point. Value will be updated by 0.4 because you have the 0.75 as your maximum value. So that will be get updated. 0.37 is around 0. So that's the concept. So that's the working of Q learning. Now you will understand. I think you can understand how the Q learning works. So in the tic-tac-toe game, you are using the same concept. How what you are going to do is initially all are random. The agent will choose a random. The AI player or the computer choose a random cells. Similarly, it has to play with another person, that is a human being. He also chooses the random. How it chooses the random? Based on this Q value. Okay. So if you think these two are placed, and the agent will see which one has the highest value. How the agent knows is by learning many times. So that's all about this. Obviously, when the agent loses, it gets the rewards and punishment. And when it is tie, we can give some punishment also. So that's the thing. And the important point that I want to discuss with you is exploitation and exploration. What is this exploitation and exploration? So here the agent learns by moving from one place to another place, one state to another state, and then the values will be updated. Once the values will be updated, the agents know which way it has to go. Okay. So, for example, you are at a restaurant. You know that restaurant very well. Okay, and you have a favorite meal. So, whenever you go to a restaurant, you tasted that meal once. You know this is very good meal. And so what we'll generally do is whenever go to the restaurant, we will order that meal because we know it is very good and tasty. So that is the favorite, right? So whenever we go, obviously we will order the same thing. Sometimes we may want to taste a different thing. Means uh, we can order some other meals. Okay. So that is exploitation and exploration. Exploitation means already we know in this restaurant this is very tasty and good. So whenever we go to the restaurants, we order that. Exploration means why we have to keep on ordering that? Why can't we try a new thing? So sometimes we will try. It may be a failure, it may be a success, but we will try. So in that same way, in the in this Q learning also, the agents will follow the same steps because it's already know what is the best way because it already went once. So again, the agents try to move in the same way. But there will be some other best way also be there. But agent usually will not explore that because it will exploit the already known value. So that's why we have to keep some percentage for exploration. So even though you know the way very well, but you have to learn the new things also because it may be a best also. So that's why we need to fix some exploitation and exploration concept in the reinforcement learning for better learning. Okay. So that's the concept behind exploitation versus exploration. So now we can move on to the implementation of tic-tac-toe game. Why we discuss Q-learning means because we are going to directly implement that algorithm in our code. So without knowing that, we cannot implement that in the coding part. We will feel difficult here. So that's what that Q-learning we have to learn very well. We know what is happening in the Q-learning. So we are going to implement tic-tac-toe game in using Q-learning. I'm just going to explain the code. The library that you are importing is random. Why? Usually we will use NumPy, Matplotlib, all those things we have imported. But here we are not importing anything. We are just importing the random. Random is the library because the algorithm will learn randomly. Okay, it has to move random from one cell to another cell. It has to choose the initial state also random. So we are importing that library random in this case and initializing constant. So that is the another area. So what are the constants that we are using in the to develop a tic-tac-toe game? So initially all the cells are blank or in a board. In a board all the cells are blank. So that will be represented by double quotes. And the AI player will be represented by X sticker. So the symbol is X. And the human player will be represented by O. Okay. Training epochs. Training epochs means how many times your AI player will be trained. So first we have to understand this. Initially, the agent doesn't know anything. Agent means AI player. Nowadays, now we have to make that agent as AI player. So we have to create a AI player. The AI player doesn't have any knowledge about tic-tac-toe game. So first, the AI player has to learn the tic-tac-toe game. How it has to learn the tic-tac-toe game by by moving into the board randomly. So how it is going to learn is it we are going to create another AA player. So we are going to create two AA players, and the two AA players will play each other for 40,000 times. Okay. Once these two players plays 40,000 times, they will learn all the possible options in the games, all the rules, all the uh, what is the winning point, what is the point we have to take, win, lose, options, methods, everything about the environment they will learn by playing with each other. Okay, that is called training epochs. The training epochs means the two AA player itself keep on playing for 40,000 times. So once what you will have, once the player loses means it learns it will not do that mistake again because it's already losing that. And another time the player will play and then it win means okay, it knows the ways to win. So like that, keep on they play for 40,000 times means definitely they will have great knowledge. Okay. And then training epsilon. So already told epsilon means exploitation and exploration. Exploitation means already if the AI player knows wins means it will do the same steps. It will not try the new steps. So that's why we are keeping zero point 0.4 as a epsilon. 0.4 as epsilon means 40% it will try a new thing. 60% it will use the already existing knowledge. Okay. So that's the point behind this. Okay. And then reward win. What is that reward win means? When the player wins, AA player wins, not human player, AA player wins, it will get 10 as a reward. When the AA player loses, it will get minus 10. That is the penalty. And when it is tie, we keep as 0. So that's all about initializing the constant. So these are the things that we are going to use in our code. The first step is defining the board. I'm just running this one. The first step is defining the board. So we open a class called player. So in that player, you are going to have AI player as well as human player. And then we are defining a function. So def means the function. Okay. The function is show board. So we are going to create a board. How we are going to create a board is dot join. So this is the bar dot join that, and then board 0 to 3. 0 to 3 means we know this is the starting and this one is the 0, 1, 2, 3. Okay. So it will not, so how the thing will be placed is, okay, so from 0 to the 1, so that state you have a bar here, and then from 1 to 2 you will have another bar. Okay. And here also you have from 3 to 4 you have a vertical bar, and then from 4 to 5 you have another one vertical bar. So like that you have a bar. So while executing we will see that. Okay. So like that you will have first row. So this is your first row of the board, and this is your second row of the board, and this is your third row of the board. We know in the tic-tac-toe game we have first row, second row, and third row. So we have this, and we are calling a static method because these boards are deterministic cells. So we call the method static. And then defining the human player. So this is simple because for human it doesn't need any reward and all. Just the human has to place the values when it plays with the AI. Because we are not applying any algorithm for the human player. So the class called human player inside the main class player. Okay. And the function reward. Okay. It has two values, value and board. Okay. So board we already defined. Value is the value on the board, which cell is marking. Okay. And it doesn't have any reward because we are not going to give reward for the human beings. So pass. And make move function. So this is very important. Make move means the human player has to fix the values. Okay, has to choose a cell in the board. Okay. So how they are going to do is while true, we're calling a while function. Show board. Show board is the function that we have created already. Okay, we call that function. Okay, and then we are giving an input. The input may be 1 to 9. The human player can choose any cell in that tic-tac-toe game. And then that has been converted into integer and it is move. It's stored in this one, stored in this variable move. And if not, move minus 1 in range 9. So if, for example, the human player may press any other button like letters or where some other keys is pressing means it will raise a error, value error. Okay, it shows it is a error. Okay, and then it will print invalid move, try again. And then or else return move minus 1. So otherwise, if it's a correct range, it is in the range from 0 to 1 to 9, then what it will do is it will do a minus 1. Why it is doing minus 1 here is I already told the Python will learn from 0 to starts from 0. It's not learning from 1. So for us, it is very difficult to start with 1. If I start with 0, so we'll get confused. We'll see the first cell as 1, but the Python learns as 0. So we have to reduce that 1 here, and then we have to return that value uh, to the function. Okay. So we will give as 1 to between the values from 1 to 9 because we have 9 cells, but the Python will learn that as 0 to 8. So that's why this move minus 1 will be there. Then the human player will be getting over. Now we come to the important part of AI player. We are having the AI player. Okay. So how the player will work, how the player will learn the AI player will learn the environment is based on the Q-learning model. Okay. So in the algorithm class, while discussing the algorithm, I have explained it has epsilon value, alpha is the learning, and then gamma 0.9. So all those things, okay, and then default Q value. Why this default Q value means initially the two AI algorithms will play for 40,000 times. So when the cell doesn't have any values, it will be 0 always. So what we are doing is we are having some default value as 1 because initially the AI has to play with each other. So for that, we are giving us 1. And we are calling that variables and one by one, and then self queue. Self queue is nothing but the dictionary that we are opening to store all the values in the values of the queue. Okay, all the values of the queue will be stored in this dictionary. The dictionary one, that is SA per state and action. Then move initially none, and then self board initially it is an empty, all are empty cells, and then available moves initially the player can choose any one of the empty cells. So that is this code represent. And the next thing is it has to see each and every cell. So state and action q of x comma a. So it will see all the states. So when you see the state and action, initially if it is empty cell is none, q of s comma a is none. We have to have the q of s comma, we have to update the q of s comma a value with the default value that is equal to 1 in this case. Okay, so that is the first updation. Initially, if there is no s comma a, the default value will be taken as a s comma a. So that is the current state value. And then we are returning that value into the dictionary and it is stored here. Next time when the agent, when the player comes here, it is getting updated. So one by one time it will get updated. And I already explained exploitation and exploration. Again, self and we're taking the board. And in that mode, we'll see all the available moves. Okay. When it is empty, it has to move. And how it's going to move is based on the epsilon value. So we take a random value. Initially we random, no, when it sees available moves, whether to move or not, it have some randomly it has to take. And it is less than epsilon. We keep epsilon as 0.4. When it is less than epsilon, the action is random. The choice is random. It is going to explore. If it is greater than epsilon, okay, if the random value is greater than epsilon, then it has to use the already known information. Okay, that's the thing. So when it is less than epsilon, you are going to have a random action. You're going to explore, and we return that. And if you have the, if it is not, what it's going to do is, it is going to take all the actions. To see which one has the highest value in the cell. So in that direction, it will move. So max of all Q values in that value is moved. In that also, if there is another case, if the max Q value is greater than 1, okay, that means more than one value in the cell. So we have four, we saw four in our example, right? Forward, right, left, like that. You have multiple Q values inside a cell. So if we have all equal values, okay, if all are 1, what you do is we take again random choice. If any one is maximum, we'll move into that direction. If all are equal means, or one or two values are equal means, we have to take a random best action. Okay. So else the best move is, if that is not the case, then the best move is maximum of all the Q values. So that's the algorithm work. And then finally you have the reward for that. How the reward will have. Okay. So already you know the reward is based on the equation, right? So we will have that equation. So again, it will see the previous Q values. Okay, and it will see all the available moves, and then it will move. So how the reward will be, how the Q will get the reward? It is based on the equation. Okay, so that is the equation: previous Q alpha into reward plus self gamma. So that is the updated value. The updated value is nothing but a reward. So that will be given to this for each and every move. Okay, this is not the reward for winning. It is a reward for moving from one state to another state. So that we have seen in the example illustration. And tic-tac-toe class implementation. So initially what we are going to do is we have to set the rules of the tic-tac-toe. What the rules is a simple one. We have two players has to play, player 1, player 2. The first player 10 equal to random choice. So you have to choose any one player. Okay. Then all are empty boards initially, and play. So play is the function for the game. The first player turn, other player is second player, and we have two players, AI player and human players, player self 2. So based on who is playing first, based on that, the tickets will change. So that's the thing. And then win or lose. If the game is over, who is the player winners? That name has to be displayed. Okay, so that's the thing. And this is the how the player will. So initially, if winner equal to player ticker 0, what are the player show board, player board, and then it has to show the board, and then the name, and then if we have the reward, okay. If the player wins, we know we fix as 10. If the player loses, we fix as minus 10. So it is only applicable for AI. So we'll update the reward. Okay. Similarly, for player 1. So any player may keep the first one first. Anyway, any player can start. Okay. So it's random. So we are keeping it. If it is a tie, there also for that reward we are fixing as 0. Okay. So and then break. Okay. So when one player is playing, we cannot have the another player. We cannot, another player cannot play. So that condition we have fixed. And then for everything, we are updating the table. How the game will get over is, so that is another function. So either 3 horizontal. Okay, 3, I may be 0, 1, 2. Okay, I may be 0, 1, 2, isn't it? So that means 0, 1, 2. This is the first row. So you can put all the 3 tickers in the first row, all the 3 tickers in the second row, all the 3 tickers in the third row. So this is in the horizontal dimension. Everything is self-explanatory, just we have to go through. And in the vertical dimension, in the first j plus 0, so j is also in the range 0 to 2 actually, okay. That's the first column, second column, third column. And then diagonal. Diagonal means either the right diagonal or in the left diagonal, okay. So that is the code for this. So 0, 4, 8 is one diagonal. Another one is 2, 4, 6 is another diagonal. And finally, we can deal with block cases. So if there is no result is possible means, again, we have to return to the true or else. So this is the block case. So this is all about the tic-tac-toe game. Okay, just go through. And then training the AI player. So next we are calling the functions. 2 AI players we have called. I already told 40,000 times they are going to play that we are giving. So for in the range training epochs we are given as 40,000, and these 2 players will play. So where the play is the function that we have discussed so far. So tic-tac-toe play, they will play this game, and the result will be reward will be updated, and the training will be done. Once the training will be done, okay, we make epsilon as 0. Why we making epsilon as 0 means, so when you are playing with a human, you don't need to explore because you already learn knowledge is be enough. So when you are playing, that is not the place to learn. So we have to play with your knowledge. So we are making epsilon as 0, and then human player equal to, we call the human player function, and then the tic-tac-toe game. So that we have discussed has been played with the between AI player and human player. Let's play the game. So that's how the implementation of reinforcement learning. So the main part here is the AI player. So for this AI player, we are using the Q-learning function. We completely use the Q-learning to update the reward, to explore, to exploit, okay, to move from one point to another point, how the actions has to be, what are the ways it has to move, all those things we have explained in this Q. Other things are based on the game that we are using. For example, if you are using chess game means we have to implement all the rules for the chess game, and then we have to play. So whatever it is, if you want to learn a self-driving car means you have to give all these possibles in this play. But for AI to learn, we are using what? Q learning. So that's all about the explanation of the code. I'm just giving the runtime, run all, and then it keeps on already run all. So first it will train for 40,000 times. Okay, you can see the at the end you can see the 2 players are playing each other 40,000 times. You will have the tie A player 1, A player 1. So both are A player. So you will have A player 1. So this will be run for 40,000 times. So while learning, all the things will be updated in the queue of S, A dictionary. Everything will be learned by the algorithm, and based on that knowledge only, it is going to play with the human being. Okay, now training has been done. So this is the thing. The first line I don't know, and the board. This is the board. So we have 2 lines. That means this is 0, 1, 2, 3, 4, 5, 6. So I start with 0. So we are going to start with 1. Okay, so it's in there. So now we will play with the. I choose the first cell and I'm giving enter. So I put 0 here. The AI player with the ticker X puts here. So it is countering me. It is countering me. Let's see whether it is countering me or not. So I have to choose. I'm going to 1, 2, 3, 4. Okay. See, when I put 4, the AI player places here. So it can place anywhere, but it places here because the next time if I place 0 here, I will be win. So it is counter. It is countering me here. Okay. So I have to choose some other. path. But and I have to counter the AI also. Because if I not use this area, if I not use 3, the AI will, so I am countering the AI. So now they use some other path. Okay. So now I have to counter this place. Let's see, I will give a chance. 1, 2, 3, 4, 5, 6. Okay. I am giving 6. When I give 6, what will happen? I will choose an air. The AI player put the tickets here and the AI player wins. So it is working well. So we created this one using the reinforcement learning. Okay. So that's all about the implementation.